This is CPM Calculus Chapter 5, number 32. So we want to examine the integrals below and consider the multiple tools available for evaluating integrals and use the best strategy for each. Okay, best strategy usually means like the fastest or easiest approach, or maybe the one you like the most. After evaluating the integral, write a short description of your method. Alright, so let's go ahead and do part A. Part A is going to look at this, right? And we want to find the integral, which is the antiderivative. So what we need to do first is to expand this binomial, since it's a binomial squared, right? So that's equal to 1 to the power of 4, and we're going to distribute 2x plus 1 times 2x plus 1. So 2x plus 1 times 2x plus 1, we know that's equal to 4x squared plus 4x plus 1, right? So over here, that's just a bubble work. So we're going to write that here as 4x squared plus 4x plus 1 dx. Okay? Then we're going to be able to use, after we expanded the binomial, we can use the integration rule for the opposite of the power rule to go ahead and integrate each term separately. Okay, so this 4x squared becomes 4x cubed divided by 3, plus this one is 4x squared divided by 2, plus 1x divided by 1, right? Or we can just write this as x. And we're taking it from 1 to 4. Right? Then we're just going to go ahead and plug in these limits using the fundamental theorem of calculus now. So this is going to be 4 times 4 cubed over 3 plus 4 times 4 squared over 2 plus 4 minus, and I'm putting parentheses because we're going to want to distribute the negative to all the terms, 4 times 1 cubed over 3, which is just 1 times 4 thirds, plus 4 times 1 squared, so it's just 1. When we multiply by 1, we can leave it out. Plus 1. Alright? So we can use our calculator to do this. 4 times 4 cubed divided by 3 plus 4 times 4 squared divided by 2 plus 4 minus, and then in parentheses I'm going to put 4 thirds plus 4 halves. Well, that's just 2. I'm going to go ahead and write 2 plus 1. Enter, and I get 117. Okay, and for integral, I always like to put some units, and we know it's unit squared because the integral represents area beneath the curve. Alright, let's go on to part B. Part B, we have the integral from negative pi to pi of x times cosine of x. Alright, so this one we have to use some tool other than what we just did with the reverse of the power rule, because we don't have a rule right now to go ahead and do this. So what I would do is to go ahead and graph this function, because when you graph it, you're going to see something interesting, because we know cosine of x, right? Let's just quickly graph cosine of x. It looks like this, right? Cosine of x we know is an even function, while x looks like this, y is equal to x, is an odd function. So when we multiply them, we're going to get an odd function. So let's go ahead and see this. X times cosine of x. Make sure your calculator is in radians mode, and then go ahead and graph. Right? So that's exactly what we kind of expected. When you multiply these together, you're going to get an odd function, right? That looks like this. Goes down, up, down, up. I'm not doing it justice here. Down, up. Oh, I'm I'm really doing a bad job. Anyway, you can see here that it's odd, right? So why did I care to say that it's odd? Well, because we were able to graph it and we see that it's an odd function, we're going from negative pi to pi, which means we're going to be adding the area on the left to the area on the right, and they're going to cancel out. Okay, so that means this is equal to 0 units squared. Okay, and we could say this because it's odd. It's an odd function. Also, we could have used the integral feature of our calculator. So if I go to F3, calculate, go down to integrate, put in the function x times cosine of x, right? Comma x is our variable from negative pi, comma negative pi, second over here, comma pi. Okay, we evaluate the integral using our calculator. It's also going to tell us 0, right? As expected. So that's another way we can do this one. We could have used our calculator for part A as well, but that one's pretty simple. We could use what we did using the reverse of the power rule for integration and then the fundamental theorem calculus. All right. So I'm just kind of explaining my method instead of writing a short description, but you should definitely write your short description. Part B. Now we're on part C. Part C, we have the indefinite integral, right? We don't have any starting and stopping point. We don't have the boundaries of 2 sine squared x plus 2 cosine squared x dx. Okay, so that means graphing it probably won't help because we don't have regions that we're looking specifically at, right? So we had to think of something else. Well, what I would do first is to look here at the function we're trying to integrate and see, is there anything we can apply to this that we know from the past, right? Out of our toolbox. So what I would do now is I see 2 is multiplied by sine and cosine squared. They're both squared. So that reminds me of the Pythagorean theorem, right? For trig functions, which remember was sine squared of x or theta plus plus cosine squared of theta equals to 1. And this is true for all values of theta or x. So if I factor out a 2, we get sine squared of x plus cosine squared of x, right? Just factoring out a 2, we get this. So that means that's equal to the integral of 2 times 1 of dx, which is just integral of 2 dx, right? Then we could do the integral of 2 dx using the reverse of the power rule, makes this 2x to the power of 1 over 1. Since it's an indefinite integral, we have to include plus c, right? And don't forget to write your short description of the method you used, right? This was the Pythagorean theorem. Or trigonometric functions, right? And then we were able to go ahead and apply the opposite of the power rule for integration. All right, finally we have D. Here we have the integral of t squared over 2 minus 2 over t squared dt. So what I like to do here is, well, I would just use the reverse of the power rule. But first I want to make this t squared over 2 minus 2 to the power of, 2t to the power of negative 2. I want to bring this up from the denominator, because then I could use the opposite of the power rule, right? When I integrate t squared over 2, that becomes t cubed over 2 times 3. Minus, integrate this, it becomes 2t to the negative 1 over negative 1. Right? And don't forget, since we have an indefinite integral, it's plus c. Then we can just simplify this, and it becomes t cubed over 6 minus Well, the minus and negative 1 here are going to cancel out, so it's plus 2t to the negative 1, or you can even write this plus 2 over t plus c, either way. Okay? So again, the method I used was to first just simplify the expression so we don't have any powers in the denominator or any variables, then to use the reverse of the power rule for integration. Don't forget the plus c because it's an indefinite integral. So there we have it. That ends CPM Calculus Chapter 5, number 32.